All right, good morning, everyone. Hope you all had a nice and restful break. I want to start off by going over our calendar and our syllabus, and as well as some changes for this semester, and also seeing if you guys have any questions about this upcoming semester. So first thing off of my homepage website, you're going to see class calendar. There's also a preview from January to May, but this is not set in stone. So if you want to just kind of get an idea as to what is coming up the next few months, you can look at that. I have a draft of our syllabus, but some of the things are not set in stone yet. So kind of waiting on the district for that. But I also have all this information on the Chapter 4 page, which I included in a link under the meeting chat. So to get there, you can go to Calc Class Notes, go all the way down to Chapter 4 Integrals. And we have a bell schedule. And then starting next week, we have the emotional learning advisement period that's going to take effect next week. Wednesdays are full instruction days, no more asynchronous Wednesdays this semester. Okay, click on the syllabus here. And this semester, we're going to be covering chapters 4 through 7. We'll treat chapters 5 and 6 as kind of one unit. And then, so we'll have a test and quiz in each unit except for chapter 7, where we're only going to have a test. And then we'll have a couple of quizzes and tests during our AP exam review to get ready for our AP exam, which is that first Tuesday in May. Okay, so we're adding a few things here with our grades. The big thing is homework. So homework is going to be worth a grade this semester, but it's only 5%. So it's not going to kill your grade if you miss a few homeworks, or if some of the homework is late. It's going to be a fairly minimal amount in the overall perspective here. The thing that we're still unsure on is whether the quizzes will have their own category under formative grade, or whether we're just going to put quizzes and tests all under summative grade and just make the tests worth more than the quiz. So either way, tests are worth more than quizzes. We just don't know whether to put it under formative grades or summative, or everything under summative. But either way, they're going to count. Okay, quiz and tests are both going to count towards your grade. Okay, so we have a quiz and test for chapter 4. We have a quiz and test for chapter 5/6, a test for chapter 7, 2 pre-AP FRQ quizzes, and then we have a pre-AP test that's going to be worth 2 test grades. Most of you will probably exempt from the spring final exam as long as you have taken all these previous tests and quizzes. You'll be eligible to exempt from the spring final exam. But if you're trying to improve your grade, you can always potentially take the final exam to see if it helps your grade. And so this last 15% may not apply for many of you. Okay, one big change this semester is that recovery, there's still going to be recovery for every test and quiz, but this semester you can only recover up to a 79. There's no longer the recover up to an 89 possibility. So just want to make sure we are on the same page there. Homework is worth 5% of your grade. All the homework assignments are going to be due by midnight before the formative or summative assessment. So our first upcoming quiz is next Friday. So that means your homework assignment is due by Thursday midnight. And I'm going to create an assignment through Teams. You're going to just submit it through Teams. And I'm only looking for your homework assignment. So no longer do you have to turn in your notes or your classwork. just your homework assignment. If you turn in late homework, I will accept it, but it can only be up to 70%. But even then, minimal impact on your grade. Okay, so those are the main things I want to highlight off the syllabus, and I'll let you know if there's any upcoming changes or decisions that the county makes that impacts what I have said. So, but I'm pretty sure these are gonna stay. But I know there are a few things that are still up in the air. So I'll let you guys know when I find out. So back to the chapter 4 page. If you click on the homework calendar, okay, click on the homework calendar here. And here are your homework assignments. So you're going to have homework assignments on most days, except on some of the quiz review days and also obviously on the quiz day. So these problems are all coming from 4.2, and I'll show you where you can access these homework problems. And then 4.1, next week, we'll have a quiz review starting next Wednesday, Thursday, and then quiz on Friday. So if you go back to your chapter 4 page, you see at the very top here, textbook problems. These are where your problems are going to be, 4.2 here. Okay, so at the top of every unit, I have the link to your textbook problems. And also, I'm assigning mainly odd number problems for your homework. So you should be able to check all of your answers using the Homework Solutions Calc Chat. So if I click on this Homework Solutions Calc Chat, right now I have it linked to chapter 4. So it's already in chapter 4. You go to 4.2. Let's say you want to look at number 11. Then you just hit go, and it'll show you the full solution for that problem. Okay, so everything that you need for homework should all be right here at the top of the page. Okay, do you guys have any questions? Okay, so we're going to start today with 4.2a notes, summation notation. So this is a bit of a introduction or kind of a background information that we need. Eventually, we're going to work our way to antiderivatives, which is the inverse procedure of derivatives. Derivatives is related to slope. If we undo slope, then that process is going to be area related. So tomorrow, we're going to be discovering that we can use rectangles to approximate the area under the region. And then from that approximation, we're going to move towards finding the exact area under the curve. But we need some background tools, some introduction tools that we're going to need for tomorrow and moving forward. So we're starting off with summation notation, sigma notation. So sigma notation is given by this expression here, this notation here. And all this is saying is we're just adding a bunch of terms together. Okay, this just indicates that we're going to add a bunch of terms together. So to start off, we have something called the index. Index is the variable that we're going to be using. 2 here is the lower bound. It's the first number that we're going to be putting into the variable. And this 5 here is the upper bound. This is the last value that we're going to put into the variable. And this a sub I is a rule of sequence. This is the argument expression. We can also call this formula rule of sequence. Okay, basically the formula that we're going to be putting the variable into. So let's say we start off with this summation from 2 to 5 of a sub I. The way we're going to work through this is we're going to identify our lower bound. So put the 2 in for the I, and we get a sub 2. Okay, we're always adding terms together, so the next term is always going to be 1 higher than what we started with. So if we started with 2, our next number that we plug in is going to be 3. So plug 3 in for I, so plus a sub 3. Keep going. The next number is 4. Plug 4 in, we get plus a sub 4. We keep going. Plug 5 in for I, we get plus a sub 5. But we stop at 5 because 5 is the last value. It's our upper bound. It's the last value that we put into the expression. Now, some students think that this 5 means that there are 5 terms, but not necessarily, because in this case, we're starting with 2, so there's only 4 terms. The 5 means that that's the value that we plug in. That doesn't mean that we have 5 terms that we're going to be adding together. Okay. So let's practice applying that for this example. So if I want to find the sum of these terms, I'm going to follow the rule here. Start with my lower bound, plug 2 in for I. So I get 2 squared plus 1. And the I squared plus 1 is all part of my notation. It's all part of my, my function. Okay, so I'm done with 2. Next up is 3. Plug 3 in for I. I'm done with 3. I'm going to plug 4 in next. And I stop at 4 because 4 is my upper bound, the last value that I put in. So 4 plus 1 plus 9 plus 1 plus 16 plus 1 gets us to 32. Okay, any questions here? Now, if we only had a few terms to add together, that's not too big of an issue, right? If there's only 3 terms, 4 terms, 5 terms, not a big deal. But imagine if we had a lot more terms. Let's say we had 10 or 50 or 100 or 500. We want to find a more efficient way of adding those terms together. We'd rather not add those terms, individually. So we have these summation formulas that can speed up the process if it falls under specific categories. So if I have summation 1 from 1 to n, then my sum is just going to be whatever my upper bound is. So let me show you what that could look like. Let's say I have summation from 1 to 5 of 1. If I want to work this out individually, I plug 1 in for 1. There's no variable here, so it'll stay 1. If I plug 2 in for this function into this rule here, I'm still going to get 1. Plug 3 in, I get 1. Plug 4 in, I get 1. Plug 5 in, I get 1. I stop at 5 because that's my upper bound. I add those together, I get 5, which is the same thing as my upper bound. Okay. Summation I, we can add all those terms together, but I want to also show you that this rule also works. So I want to show you an example of that. Let's say I have summation I from 1 to 5. So working this out manually would mean I plug 1 in for I. Next up is 2. Next up is 3, 4, and 5. Okay, I can add all this together, or I can use this rule here. And this rule just says take the upper bound and put it in for the n. So if I put 5 in for the n, I get 5 times 5 plus 1 over 6. Oops, over 2, sorry. So 5 times 6 is 30. 30 divided by 2 is 15, which is the same thing as if I added those terms together. But you can see how this can be a time-saving feature, especially if this is a larger number. Okay, we have a rule for I squared as well. We have a rule for I cubed. And this fifth rule just says that if I have any coefficients that's part of my rule, I can always push it out in front. And the advantage of pushing out in front is we can isolate the parts that is going to change, and then that coefficient can just tag along after we find a suitable replacement for our summation, for our formula. So let's practice using these summation formulas with these below examples. So if I have summation from 1 to 8 of 3i squared plus 2, I could manually enter this in, but we're going to practice using our summation rule. The first thing I notice is that there is nothing that's hindering these terms. There's nothing outside the parentheses. These are standalone terms, right? Nothing is impacting. There's no exponent outside we have to resolve. These are ready to be separated. So I'm going to separate these into individual terms, each with their own summation rule applied. So okay, I'm just going to split them up into their individual terms. And I'm going to push these coefficients out in front to make it easier for me to match one of these 4 rules. So I'll push 3 out in front. I'll push 2 out in front. And if I push a 2 out in front, there's still a 1 left over, right? Because 2 times 1 is 2. That just makes it easier for me to see how I want to apply my rule. Okay. Summation I squared, I have summation 1. I have clean substitutions for these. So I'm just going to apply my rule here. So summation I squared is n times n plus 1 times 2n plus 1 over 6. My n is my upper bound, which is 8. So I'm going to put 8 in for all the n's. So 8 times 8 plus 1 times 16 plus 1. The 3 just hangs out in front. Summation 1 is just going to be my upper bound, n, which is 8. And now we just use our calculator to get our results. Okay, so let me stop for a moment here. Any questions that you guys have? All right, let's look at example 3. The thing with the example 3 is that there's an exponent that is impacting a clear view of what's really going on. So we need to resolve this first. We're going to expand this out, get the parentheses to go away, and then we can begin to separate and find out how our summation formulas can help resolve our sum. So we're going to expand first. So I plus 2 times I plus 2 is just I squared plus 2i plus 2i, so plus 4i plus 4. I'm going to assign each term with their own summation. And while I'm at it, I'm going to just push the coefficients out in front. and we're going from 1 to 10. I'm going to box off the parts that I want to substitute. Summation I squared. My upper bound is 10, so 10 times 10 plus 1 times 20 plus 1 all over 6. Summation I is just n times n plus 1 over 2, so 10 times 11 over 2. And summation 1 is just n, which is just 10. Any questions here with 3? Okay, number 4 looks more complicated because we have more variables. But one thing I wanted to point out is that instead of I being the variable, now our variable is k. So after we do our cleanup, we're going to be looking for either summation k or summation k squared or summation k cubed. Okay. And the second thing is that our upper bound is in terms of n, which means that our answer is going to be in terms of n. So keep in mind that n is the constant here. So we'll treat n the same way that we would a 2 or 3 or 4. We're going to push all the n's out in front and treat it like a constant. Okay. And then our final expression, our final answer will be in terms of n. So I'm just going to distribute this through here. Let's resolve the parentheses first and see where we're at. Okay. I have my 2 summation terms here. I'm going to push the 1 over n out in front. I'm going to find a suitable substitution. Summation k squared, I'm treat it the same way that I have to do summation I squared. So my upper bound is already n, so I'm just going to copy this down exactly as I see it. Sorry, there's a 1 over n down in front here. Summation 1 is just n.
Mr. Yang?
Yes, question.
For the lower bound, why do you use I equals 1 instead of k equals 1?
Oh, sorry. Yeah, that's my bad. It should be k. Thank you. Yeah, my variable is k, so I should have kept that as k. So the 1 over n is out in front. It can cancel with the n up at the top because these are both multiplied. No addition and subtraction is preventing us from being able to reduce. And I can also take an n out from here. So if I FOIL this out, I get 2n squared plus 3n plus 1 all over 6 minus 1. And minus 1 is the same thing as 6 over 6. I can just do a quick common denominator, and that can allow me to merge these fractions a little faster. So I'm going to combine those like terms in the numerator, and my denominator is going to be 6. Okay, so take a moment, look over what we put down. Any questions here? Okay, let's go to the back page. Okay, limits as n approaches infinity. We've seen this before. Finding horizontal asymptotes, we just compare degrees between numerator and denominator if we're approaching infinity. So let me just give you a quick example here. Let's say I limit as n approaches infinity. Notice my lower degrees don't matter. I just want to pick out my highest degrees. My highest degrees match. So it just take the coefficients, and that's my limit. Another quick example. Now, if I pick out my highest exponent, and if your denominator has a higher degree than the numerator, then your denominator is growing at a faster rate than the numerator, which means that your limit will always be 0. Right, so these are the most likely ones that you're going to be seeing as we work through these problems here. Okay, so let's do example 5 here. Find the limit as n approaches infinity for our function s sub n. I'm just going to rewrite this here. Okay, merge those together. My highest exponent is 2. They match. I just look at the coefficients in front, which is 1 over 2. So it's just 1/2.
And can you show what's back over on the right side?
Yeah. Okay, so example 6, we're going to do the same thing. We're going to try to clean this up, but now we have to resolve an I that is standing in the way for us being able to see clearly our degrees. So we're going to go back to the first page and find a substitution for I. But let's see how far we can get by merging this together here. So I get 4i over n squared. We talked about how 4 and n squared are just coefficients. They're constants. So we're going to push the 4 and n squared out in front and just isolate the I, because that's the rule that we want to use, right? We want to match one of these rules. And anything else that's not part of the rule, we're just going to push it out in front. Okay, so these are the same things. It's just I'm kind of making it so that it's easier for me to see what needs to be replaced. So I have a perfect match for summation I. So convert that to be in terms of n. And once everything's in terms of n, then we have a much easier time matching our degrees. So summation I is just n times n plus 1 over 2. Okay, we're going to fold this out, but I want to show you something, especially when we're dealing with problems that have multiple expansions. I just want us to be able to expand that first term. So if we can get to the most important term, then the rest we can just ignore. Okay, so we know that 4n and n is going to produce the highest exponent. Everything else is going to be lower. So it's just going to be 4n squared plus whatever comes after it, but has no impact on our answer because we've already isolated the highest exponent. We find a match. Everything else we can ignore. So 4 over 2 is just going to be 2. And this is a kind of a time-saving feature, especially imagine if you have multiple foiling to do. Rather than spending all that time, just pick out what's going to cause the highest exponent, and then we can ignore the rest. Okay, last example. This is requires a bit more expansion, right? We have to get rid of all the parentheses before we can start separating things apart. So I'm going to go through some foiling process here. So just that piece is going to give me 1 plus 2i over n. Combine some like terms. And then once I foiled this parentheses out, I still got to distribute the 2 over n through. So that's going to help me get a clear picture of my individual terms. So I foiled out my parentheses. I distribute the 2 over n through, and this is what I'm working with right now. Okay, any questions up to this point? All right, let's start separating these with their each term with their own individual summation. I'm going to push all the coefficients and n's out in front because I just want to see what needs to be replaced. Okay. All right, is everyone following my steps so far? Any questions so far? So once we're here, we know exactly what needs to be replaced, right? Summation 1 is just going to be n. Summation I is just going to be n times n plus 1 over 2. And then summation I cubed is just n times n plus 1 times 2n plus 1 all over 6. Okay, 2n over n. That's a nice matching degree here. We'll deal with that later. Here, I'm just going to pick out my highest exponent, 8 times n times n. There are more terms, but I know that 8 and an n is going to give me my highest degree, so I just need that first term. I know there's more to it, but it's not going to have an impact with my fraction. And that's just a time-saving feature that we can use, right? Like, why go further when you already know what is going to dictate your limit there? In the last term, you see how there's multiple parentheses. This is a little painful to expand, but we don't have to do that. Let's just pick out the highest thing that we're going to get out of this. So 8 times n times n times 2n. We know that's going to produce the largest value, highest exponent. Everything else is going to be a lower exponent. So 8 times n, that's 8n squared, times 2n, that's 16n cubed. There's a bunch of more terms, but has no impact on our answer because we've already isolated what we need to find. So each fraction has a matching degree. So 1 over 1 is 2 over 1 is just 2. 8 over 2 is just 4. And then 16 over 6. Make the calculator clean that up for us, and we get 26 over 30. I'd give you guys a minute to copy that down if I was going too fast. Okay, any questions that you guys have?
I have a question.
Yeah.
Why is I cubed in the second line? Like you go from 8i
Oh,
squared.
sorry. I messed up. This should be I squared, right?
Yeah.
Yeah, my bad. Correct that. I don't know why I put I cubed there. I think I saw the n cubed and I just made that mistake. But I think I picked out the right one, though. Yeah, everything else is right. I just, sorry about that mess up there. It should be I squared. Good. Any other questions that you guys have? All right, let's see. Yeah, that's basically all I have. You guys have homework tonight. Look on the calendar, page 263, 264, 1 through 19 odd. And you can just find that off of the 4.2 textbook problems at the top of the page. And then you can check your answer with the homework solutions under CalChat. And you're going to be turning in your homework all bundled together by next Thursday. So I will create an assignment through Teams, and you just need to turn in by next Thursday to get full credit. Okay. And I'm trying to limit the number of homework problems to between 5 and 10 problems. Just enough for you to practice, but not to overwhelm you where it's going to take more than 15 or 20 minutes to do. Okay. Tomorrow we're going to continue 4.2. We'll spend the rest of this week on 4.2. And then our first upcoming quiz is next Friday. Okay. I'm also going to have some more kind of structured help sessions. I'll announce it ahead of time. So I'm going to have a help session tomorrow morning at 7:45. I'll have a help session Friday afternoon at 3:30. So I will send that out in a text remind. So you guys, if you're able to attend, and if you want to attend, or if you want to ask questions or see me do some of the homework problems, I'll be happy to do that. But if you can't attend, that's fine. You can always access those recordings. I'll record all the help sessions. Okay. All right, that's all I have. Hope you guys have a great day. I'll see you tomorrow. Take care, guys.
Thank you, Mr. Yang.
Thanks.
Thank you.
Bye.